Right, now that we talked about linear equations and inequalities, it is a good time to talk about another very common type of equation called a quadratic equation. So as we saw before, a linear equation is one where you have x or some unknown to the power of 1, and then you have a bunch of constants around it. And we learned that we can usually solve those equations by rearranging the terms. So, for example, we can't simply subtract b from both sides of the equation, so we're left with this second line. And then we can divide both sides by a, and that gives us the answer for that particular equation. And in the similar manner, if you have something that is like this, so you have x to the power of 2, and then you have two constants a and c, then all you need to do is rearrange it to solve for x. So in this particular example, you have x squared equals to 16. So basically what that means is that you can have two solutions. You can have x equals to 4 and x equals to minus 4. Now that's different from what you would normally get from a linear equation, because as you can see, there are two possible solutions and both of them are correct. And the reason for that is that in order to solve an equation like this, you need to get rid of that square on the x. So one way to do that is to take a square root of both sides. So this is basically what you can do. So if you take that, the square root on the left hand side is going to cancel out. But this particular one here is going to be plus or minus, because when you take a square root, you have to take into account that it's a plus and minus. So in this case, x can take on any value, either plus 4 or minus 4. And you can check that, because if we plug these two values into the original equation, so 4 squared is going to be positive 16, and minus 4 squared is going to be minus 4 times minus 4, and negative signs cancel each other out when they're multiplying or dividing, so then we're going to get positive 16 as well. There is a particular type of equation that we cannot solve by this means, and it is anything that has a negative square root in it. So if you have something like x squared equals minus 1, then you can find that by taking the square root of both sides, you're going to get something like this. And it turns out that there's no number that you could possibly square that would give you a negative number. And the reason for that is that anything that you square, whether it's a positive or a negative, is always going to become positive again. Because you know that if you have a negative number, so negative times negative equals positive, and anything that is positive times positive is also negative, also positive. So it turns out that there's really no real number that you can actually put into this equation that would be valid. And this is where we say that there are simply no real solutions to that equation. So no real solutions. There is a way to solve it, and it requires using another type of number, which is even higher up in the ladder. So it's even higher than real numbers, and it is called a complex number. Now, you don't really need to worry about that at this stage, because complex numbers is something you're going to learn about if you do extension to mathematics in year 12. Or if you go to university and maybe in first year mathematics they teach about complex numbers. But other than that, you don't really need to worry about complex numbers at this stage. You can look it up just to try and see what it looked like. But yeah, at this point we just say that there are no real solutions. So now what we can do is let's do some examples just to find out how to solve this. So we're given an equation x squared minus 64 equals to 0. Now, the first thing that comes to mind here is that we can simply just add 64 to both sides. So we can have x squared equals to 64. And then we can take the square root of both sides. So that becomes x equals to plus or minus square root of 64. And now what we can do with that is, well, what number multiplied by itself is 64? Well, we know 8 is one of them. So that's going to be your answer. Normally, you would just write it as this, or you can write it as x equals to 8 or x equals to minus 8. Either way is fine, but this one is more compact, so you can just leave the answer in that form. Question B is the same thing, so we could subtract 7 from both sides, but oh no, I can anticipate what's going to happen here, because if we take a square root of both sides, we're going to be left with this situation, and we already talked about how this kind of thing has no real solutions. So that's what we would write in this case, no real solutions. There is a solution in terms of complex numbers, but because we don't know about complex numbers yet, we cannot really say anything meaningful about that. So we just write no real solutions. Okay, now for this one, what we're going to do is we can add 5 to both sides, so this becomes 3x squared equals to 12. And then divide both sides by 3, so this becomes x squared equals to 4. And then taking a square root of both sides leaves us with plus or minus 2. So that one's pretty straightforward. Now, this particular question gives us an equation, but then it is giving us a condition. So the condition says that x must be less than 0, which means that x must be a negative number. So let's see what that is going to turn out to be. So we start with this equation here. So one thing we could do is just subtract 13 from both sides. So we're left with minus x squared equals to 3 minus 13 is going to be minus 10. And now we can multiply both sides by minus 1. So this is going to be x squared equals to 10. And then we take the square root. That's going to give us plus or minus the square root of 10. And what we can actually tell from this condition here, we need to be very careful when reading the question. You need to include the conditions in. So x can only be, according to the condition, a negative number. So that means that we cannot have the positive here. Our solution can only be the negative option here. So that's going to be the solution. And because we cannot really find any whole number that multiplied by itself gives us 10, then we just leave the answer as it is. We could approximate it by putting the calculator. It's going to be something like 3.16. But obviously, we usually prefer to have numbers in their exact form. So we're just going to leave the answer as it is. If the condition said something like x greater than 0, then all we would need to do is, instead of selecting the negative answer, we would just select the one that is positive. So we would have x equals to plus square root of 10. And that's pretty much what it means. It's just that based on this condition, choose the answer that fits that description. I mean, of course, both answers are correct for this equation, but the problem is only looking for the values of x that are less than 0. So in that case, we would just choose this one. For this equation here, well, we could multiply both sides by 10, so that becomes x squared equals to 121, so 121. And then we can take a square root of both sides. That's going to become plus or minus the square root of 121. And what we can tell from this is that actually the one number that could be squared to become 121 is 11. So we could actually write x is equal to plus or minus 11. So that's our answer. In this final question, it's very similar, but now we have the x in the denominator. But that's not much of a problem because we know we can just multiply both sides by this to get rid of it. So we can have 1 equals to 20 times 5x squared. That's going to be 100 times x squared. And now we have x equals to, so let me just go down here. X equals to plus or minus the square root of 1 over 100. Alright, so we divide both sides by 100, then take the square root. And when you have the square root of a rational number or a fraction, it's the same as writing the square root of each number individually. So we can write it like this. Now the square root of 1 is just 1. But then the square root of 100 is 10. So that's going to be our final answer for that question. So hopefully this is giving you a better idea of what kind of equations you can find. And there are really a lot of other options we have here, but at least we know how to solve linear and some simple quadratic equations of this form now. And in the next video, we're going to do some more examples based on this.